So welcome to this latest video 162 Maths, and in this video we'll be going over the GCSE Maths topic of iteration with a focus on how to form the iterative formulas and finding solutions and limits to the iteration. Now, as well as iterations providing a term-by-term sequence, they can also be used to solve equations. Now, this works in a similar way to solving equations using trial improvement or trial and error, but in a more logical way. Now, if you're not sure about what trial improvement is, this is when you were given the equation, so let's just make one up. Let's go for x squared minus 3x equals, let's say, 13. So then what you would then do is you would then find values of x. You would substitute them into x squared minus 3x equals 13, and then you would then make a comment as to how far away it was from the answer of 13. So it works in a very similar way to solving this. So again, we could pick values of, let's say, 4. So if I substituted 4x equals 4, I'd have 4 squared minus 3 times 4, which is going to give me 4, so that's too low. So then I would try 5, so I've got 5 squared minus 3 times 5, which is 10, which again is too low. Then I would try 6, so I've got 6 squared minus 3 times 6, so that's going to be 36, take away 18, which is 18, which is too high. So then I would try a value that's between 5 and 6, so I might try 5.5 and so on, and I'd continue that until I got an answer that's extremely close to 13 with an x value as to the degree of accuracy that I want. So for example, to 2 decimal places or 3 decimal places. So trial and iteration works in a very similar way of solving equations like this, but in a more structured way. Now, when working out a series of iterations, you may notice that the terms as n continues or tends towards infinity, that the value of the term will either converge to a number or diverge to infinity or minus infinity. So in other words, what happens is if I draw a set of axes, and let's say the x-axis is my n, and this is the value of xn plus 1. So what you might find that if the numbers get bigger or smaller, that they might actually converge to a particular number. So for example, they tend to look like this, where it tends to be at this number here. Or what might happen is that the numbers may diverge, which basically means that they head towards minus infinity or positive infinity. So you might find that they go like this and they just get bigger and bigger, or they might get smaller and smaller and smaller in terms of the other direction. So again, here we're all just talking about positive infinity, so it's just a case of that it just gets bigger and bigger and bigger, or smaller and smaller and smaller as it tends to infinity. Now sometimes it can oscillate and gets bigger and smaller as it converges, or it can become periodic. Now oscillating basically means where if I just, let's say it becomes a particular value, but you might find that your values of xn or x2, x3, x4 as that it continues may get something that looks like this, where it just gets smaller and smaller towards it as it tends to a value. Or what might happen is that it may become periodic. Now it can be oscillate and tend towards infinity. So for example, it could look something like that. It just gets bigger and bigger and bigger. Now in terms of oscillating becomes periodic, that's when it only becomes certain values. So for example, as n increases, it may bounce between two certain values or a series of values. So if you find like x2 equals 3, x3 equals 7, then x4 equals 3, x5 equals 7. So as you can see, the numbers of my x values are repeating, so that would be classed as where it's periodic. You may get something that oscillates, so for example, x2 might be minus 4.32, or 5 I should say, x3 might be 7.23, x4 might be minus 5.61, x5 might be 8.32. So as you can see, the numbers are getting smaller and bigger, but they're going from positive to negative, positive to negative. So that is an example of where it oscillates. Now in terms of how to form an iterative formula, now in some cases this will be given to you in the exam, but sometimes you might get asked to prove how the iterative formula has been created. Now the general method for this is if you pick an x in the solution, call it any other x's y's, then the third step is rearrange to make x the subject, and then once you've done that, replace x with xn plus 1 and any y's with xn. Now if that makes absolutely no sense to you at all, do not worry. So let's say we want to form an iterative formula for, let's go for 3x squared minus x equals, let's say 10. So in this particular question, as you can see, I've got two x's. I've got this one and I've got this one. Now let's say I want to make this x, the one that's in the x squared, the subject. So I'm going to pick this x. So looking at step 1, I've picked that x, I'm going to go for that one. So then the next one is I'm going to leave that and leave it as called as x, but I'm going to call the other x y. And then what I then want to do is make x the subject. So here I've got 3x squared equals 10 plus y, and then x squared equals 10 plus y divided by 3. So then x equals the square root of 10 plus y over 3. Now once you've done that, what you then want to do now on step 4, where instead I'm going to replace the x with xn plus 1, and I'm going to replace the y with xn like so, and there is my iterative formula. Now let's say I wanted to make this x the subject, so let me just get rid of this and let me just make sure that it's highlighted. So this one is making this x the subject. So now let's pick another colour that will be able to see. Let's go for purple. So let's make this x the subject. So making that x the subject, I'm going to have 3y squared minus x equals 10. So I want to make that x the subject, so I take the 10 over and I take the x over to this side. So I end up with 3y squared minus 10 equals x. And then from this, I replace the x with xn plus 1. And I replace the y with xn. Now you might think to yourself, well, how do I end up with two different iterative formulas for the same equation? Well, if you notice that the original equation is a quadratic, and you tend to find that with quadratics you can tend to have two solutions. So one solution I would use this iterative formula, and for the second solution I would use the other iterative formula. So again, they may ask you to find both, they may ask you to find one, but if there are two x's in the original equation, then there'll be two different iterative formulas that you can create. So let's have a look at some of these examples. So in this question here it says, show that the equation x squared plus 3x minus 5 equals 0 can be rearranged to form the iterative formula of xn plus 1 equals the square root of 5 minus 3xn. Now because there is a square root involved, I'm going to assume that it's this x that we want to make the subject. So taking this question, if I have x squared plus 3x minus 5 equals 0, I want to make this x the subject, so I leave that as x, but I may turn any other x that I see into a y. So then all I want to do then is make x the subject, so I've got x squared equals 5 minus 3y, and then from this I've just got a square root, so x equals the square root of 5 minus 3y, and then all that's left for me to do is replace the x with xn plus 1 and replace the y with xn, and there I have showed the iterative formula. Now for question 2 it says, show the equation 4x squared minus 5x minus 7 equals 0 can be rearranged to form the iterative formula. Now in this particular equation you can see I've got no square root, so it's most likely going to be this x that I'm going to make the subject. So if I then turn everything apart from that x into a y, I end up with this, and then I want to make x the subject, so if I take this over to the side, I get 4x squared minus 7 equals positive 5x. Then all that's left for me to do is divide by 5, which equals x, and then all that's left for me to do is replace the x with xn plus 1 and replace the y with xn. And there we go, and you can see there that I've got the exact same formula. Now the next thing we move on to is showing that a solution exists between two values. And again, this is quite common for this to come up at GCSE level. Now often when you get asked to show that a solution exists between two values, to show this is the case, you need to do two things. Now the first thing is you want to make the equation equal to 0. Now in some cases this may already be done, in which then the question will be worth less marks because they've done one step for you. Now the next step, which is the most important, is that you substitute the two values that are given in the question and show that when you substitute in that the answer are one's a positive and one is a negative. Now this is known as a change of sign, and if there is a change of sign, then that indicates that a solution exists between the two values. So it's really important that you do remember these two steps when showing that a solution exists between two values. So now let's have a look at some examples. So in example 1, it says show that the equation 2x cubed minus x squared minus 3 equals 0 has solutions between x equals 1 and x equals 2. So first things first, let's just double check to make sure that the equation that we've been given is equal to 0, which it is. So all that's left for me to do is then substitute x equals 1, x equals 2 and work out the values. Now because the values are relatively small in terms of 1 and 2, could easily appear on a non-calculated paper, so again just be mindful of that. So when x equals 1, substituting 1 in, we get 2 lots of 1 cubed minus 1 squared minus 3, and 1 cubed is 1 times 2 is 2, 1 squared is 1 and minus 3, so if I do 2 take away 1, which is 1, take away 3 is minus 2. Then when x equals 2, I get 2 lots of 2 cubed minus 2 squared minus 3. Now 2 cubed is 8 times 2 is 16, 2 squared is 4 and minus 3. And again, just be mindful of the negatives and negative numbers that you substitute in. So 12 take away 4 is 12, take away 3 is 9. So as you can see, as I have a change of sign, so therefore a solution exists between x equals 1 and 2. Now it's really important that you do write what I've written in yellow as part of your answer, because failure to do so just means that you've substituted two numbers in and the examiner might be thinking, and what? So make sure that you are stating what the change of sign actually represents. So moving on to question 2, it says show that the equation x cubed plus 4x equals 1 has a solution of x equals 0 and x equals 1. So again, one thing you may want to do is to make this equal to 0 first. So I've got x cubed plus 4x minus 1 equals 0. So then once I've done that, substitute numbers in. So when x equals 0, we get 0 cubed plus 4 times 0, take away 1, which equals minus 1. And when x equals 1, we get 1 cubed plus 4 times 1, take away 1, and that's going to give me an answer of 4. So again, as you can see, we've got a change of sign. So therefore, a solution exists between x equals 0 and 1. Now, one thing that you might also want to do, now in terms of making it equal to 0, although it's good practice for you to do that, particularly with certain equations, you don't necessarily have to. Now, if I just get rid of all of this, and let's say I didn't make it equal to 0, then basically what you're therefore doing is not looking for that change of sign, and instead you're looking for a solution that is between 1. So when you are not making equal to 0, which again is not something I would recommend, it is still possible. So not making equal to 0, so when x equals 0, I'm going to get x cubed, I'm going to get 0 cubed plus 0 times 4, or 4 times 0, and that gives me an answer of 0. Then when x equals 1, then I'm going to get 1 cubed plus 4 times 1, which equals 5. Now with this, as you can see, these two values are between, let's get a colour that actually works. So as 1 is between 0 and 5, a solution exists between x equals 1 and 2. So it is possible for you to answer this question without making the original question equal to 0. But again, remember, you're therefore not looking for a change of sign. And the only reason why I recommend doing the change of sign is only because this is kind of leading forward into an A-level maths topic where you are definitely looking for that change of sign. So if you've been told that you don't have to make equal to 0, that's correct at a GCSE level. But taking knowledge further, you will be needing to rearrange it to make equal to 0 and looking for that change of sign. Now the next thing we move on to that's often asked at GCSE level with regards to iteration is finding limits and solutions. Now as mentioned, sometimes an iterative series can converge or tend towards a particular value. Now often this is the solution to the original equation when it is equal to 0. Now this limit or value is often found by repeating the iteration until the value stabilizes to a degree of accuracy or decimal places. So for example, starting with xo equals 0, use the iterative formula of xn plus 1 equals 2 over xn squared plus 3 to find an estimate for the solution of x cubed plus 3 equals 2. So again, they've already rearranged this equation to get this, and hopefully now we understand where that iterative formula has come from the original equation. Now in this particular question it's starting with x0, so we know that x0 is 0. So what I then need to do is find x1. Now for this I'm going to use my calculator. So if I just load that calculator up, which there it is. And so from this, if I just move it onto the side so we can actually see some of the writing, which is going to be very, very difficult. So let's start by entering 0 into the formula. So we've got 2, and let me set my fraction, and I've got 0 squared plus 3 equals, and it gives me 2/3, or as a decimal 0.6 recurring. So I'm going to write 2/3, or I could write 0.6 recurring. So then I'm going to work out what x3 is. So on the calculator I'm then going to repeat the formula, so I've got 2 over, and it's going to be 2/3 squared plus 3, press equals, and it comes up as 0.5806. So 0.5806. Then I'm going to work out x4, in which I then replace the 2/3 with bracket 0.5806, close bracket, press equals, and it gives me 0.59. And just remember the other digits, 93. So then I type in x, or then I enter work out x0 is, x5 rather. So again I go back to my calculator and just change this digit to 5993, press equals, and it comes up with 0.5953. Then I type in x6, and I carry this forward until the number stops changing. Now, as you can see, by doing this manually is a very, very tedious task. So let me just change that to 5953, press equals, and it comes up with 5962, so 0.5962. Now, one thing you notice is that after x4, the first two decimal places is not changing. It's going to be 0.59 something. So as I keep going on, and let's say I'm just going to carry on doing this, I'll find that the answer stops changing. Now, on the calculator, there is a much easier way of doing this iteration on the calculator, but key thing is you need to make sure that you're doing this correctly. So I'll write down the steps in terms of how we do this, but if I then enter the first value, which is 0, press equals, then that's stored x0 as 0. Then on the next step, I then enter the iterative formula, so 2, but wherever I see an xn, I'm going to swap that with ands, and I'll put the ands in brackets, plus 3. Now every time I press equals, it will give me the next value of x. So if I press equals now, that's my x1, press equals, that gives me my x2, press equals, that gives me my x3, press equals, gives me my x5, and then press equals again, gives me my x6, and then if I keep pressing equals, you can see that eventually the calculator stops giving me new answers. So therefore, the answer is going to give, or the answer is going to equal, and I've just got rid of the calculator and I've missed it out, so let me do that again. In which I get an answer of 0.59607168. Now, obviously, a question might ask me to give my answer to 6 decimal places, 5 decimal places, 3 decimal places, in which all I then need to do is just round this number up. Now, to work out the values or solutions to your iteration by using the calculator, and all you need to do is just follow these 5 steps. Now, if the 5 steps don't make much sense, do not worry. When we go through some exam questions, hopefully you'll see all of these come into practice. So the first thing you want to do is enter the initial value, either it be x0 or x1, depending on how the question is written, on your calculator, and press equals. The next thing you then want to do is enter the formula on your calculator, replacing xn with the ands function on your calculator. And what I'd strongly recommend is that you put the ands in brackets. Then all you then need to do is press equals for every single x value that you're wanting. Make sure that you're only pressing x once and writing down the x value for the first 4 that you press your x values for. Also, make sure that you write it to the correct degree of accuracy. So if the question wants you to write your x2 values to 4 decimal places, then make sure you're writing those values off your calculator to 4 decimal places. Then to find the limit or the solution, all you then need to do is keep pressing equals until the number stops changing on your calculator. And then depending on what the question is asking you, it may ask you to give your answer to 5 or 6 decimal places. Then on that calculator, all you then need to do is just round that number up accordingly. So now let's have a look at this exam style question. Now note that this question is non-calculator, so these do appear on a non-calculator paper. So it says the sequence is defined by the term-to-term rule of un plus 1 equals un squared minus 3un plus 1. And the question is asking me when un equals 1, find out u2, u3 and u4. Now this formula is, if I just write it out again, is un squared plus 3 lots of un plus 1. Actually it's a minus, let me just make sure, and again make sure you do copy the formula out properly. So then substituting for u2, it's going to equal the previous un value, which is u1 squared minus 3 lots of u1 plus 1. So substituting those numbers in, well, u1 equals 3, so it's going to be 3 squared minus 3 lots of 3 plus 1, which equals 1. So u2 equals 1. Then for b, u3 is equal to u2 squared minus 3 lots of u2 plus 1. So if u2 equals 1, that's going to be 1 squared minus 3 lots of 1 plus 1. 1 squared is 1, minus 3 is minus 2, plus 1 is minus 1. So u3 equals minus 1. Then for c, u4 is going to equal u3 squared minus 3 lots of u3 plus 1. So then we've got minus 1 squared minus 3 lots of minus 1 plus 1. Well, minus 1 squared is positive 1. 3 times minus 1 is minus 3, but minus 3 becomes plus 3. And then we've got plus 1, gives us an answer of 5. So u4 equals positive 5. To question 2, so let's just zoom in so you can see that. This one is a calculator question. It says an approximate solution to the equation is found using this iterative process of un plus 1 equals un cubed minus 1 all divided by 4, where x1 equals minus 1. Work out the value of x2, x3 for part A. So for x2, it's going to be minus 1 cubed minus 1 divided by 4. And if I type that into my calculator, which should just load up now, so here I've got, or I can use my calculator to work this out. So to use the calculator, I enter the first value, which is minus 1, enter that, and then I enter the formula, putting the ands in brackets, and it's cubed plus, well, minus 1 all over 4. So just double check to make sure that that looks fine, that the minus 1 is not part of the power. Press equals. So my first value is minus 0.5. And I write as a decimal. And x3, if I then press equals on the calculator, gives me minus 9 over 32, which is 28125. So it's minus 0.28125. And then for part B, it then tells me to work out the solution. So if I've kept it on my calculator, all I've got to do is keep pressing equals until it stops. And so the value that it stops at is minus 0.25410168884. Now the question wants me to round up to 6 decimal places. So rounding this number up to 6 decimal places gives me 0.254102. And there we go. Moving on to question 3, it's very, very similar. So it says an approximate solution to the equation is found using the iterative process, and we've got a formula where x1 equals minus 1. And the question is asking me, first of all, to find x2, x3, and then give the solution to 6 decimal places. So again, if I get the calculator back up again. So again, enter the first value, which is minus 1, press equals. Then enter the formula, so I put bracket, ands, close bracket, and then cubed. Just notice that the formula is very, very similar to the previous one. And then we want to take away 5 and then divide by 10. So press equals. So my first value is minus 3/5, which as a decimal is minus 0.6. I then press equals again, and it gives me a bit more complicated decimal, but it's minus 0.5216. So minus 0.5216. Now note that I'm writing all the numbers on the calculator because for part A, it doesn't ask me to round any of the numbers up. Then for B, all I then need to do is keep pressing equals until the calculator stops the number from changing. So the actual answer is minus 0.5135433527. I then want to round this number up to 6 decimal places. So then it then becomes minus 0.513544, and that's to 6 decimal places. Then moving on to our last example, so it says work out an approximate solution to x cubed plus 2x minus 1 equals 0. Use the iteration of xn plus 1 equals 1 over xn squared plus 2. Start with the value of x1 equals 1. Give your answer 2 decimal places. Now for this, although it's just asking for the solution, I strongly recommend that you do write down what x2 is, what x3 is, what x4 is, what x5 is. Always try and write down at least 4 values before giving your final solution. So getting the calculator back up, and let's enter this formula. So the first thing I need to do is enter the first value, which in this case is 1. I then set up my fraction, and then how I want to set my fraction up is I'm going to have 1 over, and it's going to be ans squared plus 2. So then entering that, I've got 1 over bracket. Now the reason why I put ans in bracket is just in case the previous answer is a negative. I know that my calculator doesn't like negative numbers unless you put brackets, especially when you're squaring. So always put ans in brackets and then plus 2 equals. Now also what you want to do is just make sure that your calculator, what the expression that you've got on your line of display looks exactly what you've written. Just make sure that plus 2's aren't a part of the power and vice versa. So pressing equals, that gives me a third. So I can either write a third or I can write 0.3 recurring. Then pressing equals again gives me 9 over 19. So 9 over 19. Now if you want to, because it's not asked you for x2, x3, you could just simply write down the fraction. That's absolutely fine. But personally speaking, depending if you've got time, just do whatever you see fit. But you definitely want to write down a couple of digits. I'm not writing all the numbers, just showing that I've worked it out. If I press equals again, it gives me 361 over 803, or as a decimal, it's 0.4495. And then x5, again, it's ditched the fraction, so it's 0.5411. And then if I bring that calculator back, again, I'm just going to keep pressing equals until the number stops changing. So as you can see, the answer to this, so the solution is 0.4533976515. But I want to give my answer to 2 decimal places, so it's going to be 0.45. And there we go. And that's 2 decimal places.